So my favorite radio station in San Diego is 93.3 megahertz. So this is the frequency with which it is played. Okay? And so what I'm going to show you is how to convert between wavelength and frequency. So this is my frequency. Another way of showing the symbol for frequency is nu, so it looks like a little check mark like that. Now the formula for relating wavelength and frequency is c, which is the speed of light, equals lambda, which is wavelength, times nu, which is the frequency. And so all I have to do for these problems is plug in my values. Now the first thing you should notice though before we get started is the fact that this frequency is in megahertz. And for all the problems that we're going to be doing, we want to be in hertz. So I have to quickly convert between megahertz and hertz. And we've already done this, so this should be review. I'm going to put hertz on top, and I'm going to put megahertz on bottom. Now in 1 megahertz, there are 10 to the 6th hertz, and so my frequency in hertz is going to be 9.33 times 10 to the 7th hertz. And now I'm going to use this frequency and I'm going to plug it into this equation right here. So I'm going to do that. I know that my speed of light, it's the same always, it's 3.0 times 10 to the 8th. My units are meters per second, or meters over seconds. I'm solving for my wavelength, so I'm going to put lambda right there, times my frequency, which is 9.33 times 10 to the 7th hertz. Okay? Now in order to solve for my wavelength, I need to divide both sides by 9.33 times 10 to the 7th hertz. And when I do that, I find that my wavelength, or lambda, equals 3.215.434. And my units for wavelength, since this is hertz or seconds to the -1, and that will cancel with the seconds from my speed, it's going to be meters. Now I need to round this to my fewest number of sig figs. This has 2 significant figures. This has 3 significant figures. So my final answer, I need 2 sig figs. So my final answer is going to be 3.2 meters. And that's it.